Welcome to Study Loop.
For problem 10, I have drawn a little picture here, so excuse my crude artistic talent, but the problem setup tells us that we have an electron that is projected vertically upward with a given speed of 1.7 times 10 to the 6 meters per second into a uniform magnetic field that is oriented directly away from the observer, and we want to describe the path in this field. So the magnetic force is going to cause a sort of centripetal motion. So if I trace it out here in green, when it enters the field, it's going to start being turned like this. And depending on how big the field is, it may be captured and it will go in a circle, or if it escapes, then it will come out going directly in the opposite direction. However, if it's stuck inside here, then you could imagine it making a circle over and over again until it finally radiates away energy, which is not considered in this question. So that is the described path, and you can actually figure out the radius of motion by taking the equation for force of a point charge, which is QVB, and equating that to the force from centripetal acceleration, which is mv squared over r. You do a very quick rearrangement there to get r equals mv over qb, and we have everything we need for this, so mass, charge, velocity, and the magnetic field strength. So I'm not going to write it out, but if you insert that and crunch the numbers, you will see that the radius of rotation would be 1.51 times 10 to the minus 5 meters. However, if we have a very sharply defined region here, just like I said before, it's going to go in and then come right back out, going the opposite direction from which it came. So it's only going to do half a rotation. But this radius here is the radius that we calculated.